want to be able to graph data because by graphing data, it allows us to be able to compare the dependent and independent variables, or the x and y, or the quantities being related to each other, and see a visual relationship. And this visual relationship allows us to interpret lots about the relationship or the graph. So when we're graphing, it's important to understand and know which is our independent and dependent variables. Okay, so when we talk about independent, we're really talking about the x variable, and the dependent then would be the y variable, or the x is horizontal, y is vertical. Okay, we can also talk about the input is the independent, and the dependent is then the output. We also talked about domain and range. So domain is our input, range is our output. Okay, so it's important to connect these terms with these variables. So we want to plot the data and figure out the relationship. We want to know the quantities being related. In this case, we're relating the number of boxes of donuts to the cost of transporting. Okay, so the cost of buying and transporting these boxes of donuts. These are the quantities being related. And when we talk about the dependent and independent, we should ask the question, does the number of boxes depend on the cost, or does the cost depend on the number of boxes? In this case, the cost depends on the number of boxes, so really we should think of the cost as the dependent variable. Okay, so this is our dependent variable. And in other words, this should be our y variable, or our output. That makes the number of boxes then the independent, or the input. Okay, and we normally graph the independent variable along the x, or horizontal, and the dependent variable along the y. So here we're going to graph these quantities. So when we talk about the number of boxes, we're going to graph that along x, horizontal, and the cost we're going to graph along y, or the vertical. So the number of boxes, for 20 boxes, it costs $85. So $85 may be somewhere around here. For 30 boxes, it costs $105. $105 is going to be somewhere around here. 40 is going to cost $125, so somewhere around here. And 50, we're talking about $145, so maybe somewhere around here. Okay, so this is our pattern. And when we're talking about these patterns, we really want to know what, not just these individual dots, although these individual dots are important. These individual dots establishes a pattern. Okay, and this pattern looks to be a straight line pattern. And in fact, the straight line patterns are ones that we're going to focus on in grade 10. There are many other patterns, okay, but we're going to focus on these straight line patterns. Okay, so, and when we talk about the straight line pattern, we're talking about, we want to be able to extend this. We want to know the pattern, not just individual dots, but the whole pattern. So this pattern we're going to describe as a straight line relationship. So there's our straight line relationship. And how would I describe the straight line relationship? Well, I can kind of say that as we increase the number of boxes, it costs more to ship, okay, or to transport. The more boxes, this is a very general relationship, the more boxes, the greater the cost. So greatest the cost of purchase and transport. Okay, so, and we can maybe be even more specific with this. So it looks like as we increase the number of boxes by 10, we increase the cost by $20. And then it looks like to be a fairly regular pattern. Okay, we add $20 add 10 boxes, we add $20. So we could maybe describe this relationship as we increase the boxes by 10, we increase the cost by $20. Or we can even say as we increase the boxes, we increase the cost by $2 per box. Okay, so maybe we can write this down. We increase the cost by $2 per box. And in fact, we could probably even go back here and say, well, we start with a cost of about $45. So if I went back to 0 boxes, I can get back to $45. In fact, that $45 probably represents what we call a fixed amount. And maybe that's the transport cost, because it doesn't really cost more to transport more boxes. It just costs more to buy more boxes of donuts. So we can say that we increase the cost by $2 a box plus $45 for transport. Okay, now that may or may not be the case, but that seems like a reasonable relationship. And we can write this as a mathematical relationship, saying that the cost is equal to $2 per box times the number of boxes. Okay, so I'm going to leave that times out because that's going to be implied when we multiply, plus $45. And since the number of boxes is our independent and the cost is our dependent variable, we can write this as y equals 2x plus 45. And we can write this in function notation. And we can say that f of x, the output, f, based on the input x, is going to be 2 times x plus $45. So this is our function notation for this particular problem. So we have kind of generated this, we have this relationship in a table. We can see the pattern in a graph. We can describe this relationship in words. We're now connecting this relationship to an equation, and we can also write this in function notation. So that's kind of the stages that we're going. We're adding on more things to this relationship.